So, welcome everybody. Today's going to be a talk about the importance and systemic breakdown of automated testing. The title kind of says what it's all about. I tried to cram it in there, give an informative title. The approach today is going to be different than you might be used to, which hopefully will be a good thing. So, I think most of you will probably have heard of agile testing. And this talk is not going to be one of those talks where we're going to be talking about how testing used to happen with a lot of manual testing, manual regression testing executed by an independent department, an independent team from the development team. I think this is a well-covered topic. Most of you will know that even if you haven't experienced it yourself, that this leads to even lower quality software than you would expect than if you didn't have a testing department. So let's forget all that and focus on teams that are already working in an agile way, teams that have already adopted multidisciplinary team composition and already working iteratively. So let's assume that and go from there. Yes, okay. So, first we're going to talk about the importance of testing, and we're going to do a little bit of a thought experiment. So why does it matter? Why test anything and why automate it? Even if you feel you have an instinctive or a gut reaction to this question, let's go, just humor me and let's go through the exercise together. So ask yourself the question, would you buy a car from a company that didn't test their cars? I think the question is obviously, well, no, because it's a safety thing. Now, imagine that they tested the prototype, but didn't test the things that come out of the assembly line, out of the end of the factory. It's better, but not great. Now, imagine that they went a step further and said, okay, well, let's test every 10th car down the and that comes out of the assembly line. So that means that 10% of all the cars will be tested just for certain base functionality. But they would say the really stringent stuff, like we don't want to crash every car to certify that it's safe, so we're only going to do crash tests on a couple of cars because that's expensive. But we're just going to assume that the rest of the cars fit that same standard. Okay, that seems reasonable. Now imagine that this same company decides to make minor tweaks to the car. I think you can see where I'm going with this. Let's say the 2020 model gets all this test. Connection was interrupted. Let's try again. Oh. Okay, I'm back. Good, great, awesome. So, as I said, I don't know exactly where you last heard me, but as I said, there's a little bit of an internet hiccup here, so we're back. That's good. So again, minor changes tend to cascade and break stuff that we might not intend to touch. So buying a car where they don't test the version that gets changed, that's a problem. So again, we're assuming that we're working in an agile way, so these things you will recognize. When you decide to do testing, you got to do it every time you change something, because that's kind of the use of it. So automated testing, when it comes to software, let's forget about cars now, is really about putting your money where your mouth is, or in this case, putting your ass where your craftsmanship is. Because you want to know, did I break anything, right? You want to know with full confidence after you've released a new version, all the old stuff still works. That's regression testing, right? Regression testing isn't a specific type of test, right? It's not the same thing as unit tests and end-to-end tests where it's a category of tests. No, it's all of those things running in order to catch regressions. The word regression obviously says something. It regresses, it goes downwards in quality, right? There's a defect or something like that. So that's what automated testing is for, is to give you this constant confidence that stuff didn't break. Regression testing, as defined by the ISTQB, Certified Tester Foundation syllabus, comes down to this quote. So I'm going to read it. It is possible that a change made in one part of the code, whether a fix or another type of change, may accidentally affect the behavior of other parts of the code, whether within the same component, in other components of the same system, or even in other systems. So again, changes have a tendency to cascade onto surrounding components. So changes may include changes to the environment, such as a new version of an operating system. It might not even be code. That's the conclusion. It might also be database schemas, right, or data itself. Such unintended side effects are called regressions. Regression testing involves running tests to detect such unintended side effects. So that's the point. Regression testing, but automated. Again, we're working in a world where we don't have testing departments. Some of you may have experienced that in your career, but it's becoming, fortunately, more rare. And if you want to read or listen to a lot of those war stories, there's a lot of talks out there that I could recommend, just to see how things used to be, and how, even though sometimes the modern way of working seems bad, it's definitely better than how it used to be, with the segregation of responsibilities. Other reasons for testing might be things such as, well, how much can my system actually take? In this case, it would be capacity testing. That's also a form of testing. That's not the main focus of this talk, but that's also a type of testing, or a reason to do testing. Also, if you want to fix a bug, a good practice is to try and reproduce that bug with a test before fixing it, so that you have the guarantee that it actually was fixed, and also that if it regresses, if that bug reappears in the future, you can catch it. Then there's another category of testing, which is in the category of formal proofs. Do you know for 100%, is there a mathematical proof saying that the system will always behave within the parameters that you set? That's a different type of testing, but also that would qualify. That's even better than the type of testing which we do, which generally is specification by example. We basically have a flow. We define this, we specify this example flow, this example behavior with defined inputs and expected outputs, and that's what we generally do as developers when we write automated tests. When we do testing like this automated regression testing, it is in order to build quality in. There's this really nice quote from Harold F. Dodge saying, "You cannot inspect quality into a product." So that means it doesn't matter how much inspection you do. The best case scenario is that you catch defects, but it doesn't actually make it a higher quality product. So you shouldn't rely on inspections for quality. And if inspections reveal a defect, you should assume that there are more, because 100% efficacy, unless we're talking about those formal proofs, and even then you're limited to how well you've defined the system's behavior, right? So even with formal proofs, the human element is the weakest link. You should assume there are more defects if you catch any. And if you catch one, that just implies a problem with the manufacturing process. In this case, manufacturing is in quotes, because obviously we're not building machines, and we're not machines building code. So just like continuous integration, a good principle to apply is to shift left, right? Do more of it, do it continuously, and if it sucks, do it more often, because it'll force you to become better at it. And of course, I've said this before, if a computer can do it, a computer should do it. It is almost unethical to ask humans to do manual regression testing with these long 400-page scripts going through each step without thinking. Not only is it error-prone, but it's also dehumanizing to a point, especially when companies outsource this to low-wage companies in other continents or other countries. Right, so now that we've covered the importance, I want to briefly, really briefly, go over a couple of key testing techniques. I don't want to spend too much time on this, but what it is, let's say, a preview of a follow-up session where I want to show a couple of examples of these techniques and how they work. But just at a high level, let's cover some of them really quickly. So you can do testing or automated testing at different levels. There's the acceptance test. I think these are the ones that in many, many cases are called end-to-end tests. But it's really an orthogonal property. An end-to-end test doesn't have to be an acceptance test, and an acceptance test doesn't have to be an end-to-end test. Acceptance tests are the types of tests that if a business person were to read and say, hey, this behavior still works in the system, they would be willing to accept that system, that product, right? So they're business facing and they try to simulate actual user flows. Unit tests, on the other hand, are much more focused, much more granular, and they're really there to support the development of the software. The business doesn't look at the results and generally speaking don't care about the results, but we as developers, we use unit tests to give us really, really fast feedback that nothing's regressed. Again, that word regression testing, that's the main reason, is we want to be able to change the code with confidence. And if you've ever worked in a code base where the test coverage is extremely high, you know that feeling of fearless refactoring, cleaning things up and moving stuff around and having the full confidence that nothing broke because the unit tests pass. Of course, the unit tests do break when you do break something, but at least you have that thing to rely on, that before you merge it to the mainline, to trunk, or to master, you know that it hasn't broken anything. So those are the levels. And then I've already talked a little bit about spec by example. That's usually the type of testing we do. Those are the types of tests we write. We write example scenarios, known inputs and known outputs, and we check whether that behavior still holds after a change. Another testing technique is property-based testing, which is a very, very interesting technique. It's basically you define a set of properties. It could be conditional, like if the user is logged in, they shouldn't be able to see this and this thing. If they're, if they're not logged in, you shouldn't be able to see something. Like it can be conditional, but those types of properties should hold regardless of what state the system is in. And then you'll have this process that will force or make sure that the system gets in as many possible states as it can produce, and it will check if those properties hold. So basically you give it a bunch of rules and you randomly generate a bunch of input or a bunch of database data, and you check whether those rules still hold. So that way you don't actually write a single example, you let the computer generate examples and you have rules which are checked throughout the testing phase. So it's a different approach to spec by example, very interesting one, not used very often. There's snapshot testing becoming more and more popular. Basically, if you have a system that has a lot of functionality, a lot of conditional logic, and it doesn't already have tests, creating new test cases for this can be very time consuming. So an easy approach to this type of scenario, and it's also useful in other scenarios, is snapshot testing. You basically say, I run the code once because I know it's working at this point. I look at the output and I remember that output. Because I know that this output is valid and it's correct. Given the input that I gave it, I expect this output to be presented every time I run it again. So you remember the snapshot, and when you start changing the code, maybe you've influenced the behavior and now the output is different. And you'll be shown a text diff that compares the known snapshot to the new data, and it'll see whether or not these match. And if they don't match, you get an error. But that error might not be a legitimate error. It might actually be an intended consequence of the changes you're doing, in which case you have to accept the new state, the new output, as correct. And you have to tell your testing system, this new snapshot is actually valid, so you should remember this one and forget the previous one, and so on. You can produce a lot of testing coverage on legacy systems using this method. And then there's a mutation testing, which in parentheses I say meta because it's really a meta technique. Mutation testing relies on the existence of other tests, whether they be property-based tests or spec by example or snapshot testing. What mutation testing does relying on those existing tests, it just manipulates the code in random, semi-random ways, and it checks whether or not the tests pass. This is a very, very effective and interesting technique, because imagine that your tests do pass simply even after removing some statements from your code. That means that those statements weren't necessary for your tests to pass, which means they're basically untested. There's no assertion in your tests that rely on that line of code. So that means your tests are incomplete. And mutation testing will give you a much better degree of confidence in your coverage number. So if there's a high percentage coming out of your line coverage report, it says it's 90%. Well, maybe a lot of those lines are being covered, but they're not really essential in your testing process. Changing those lines may actually still have no effect on your test passing or not. So they're essentially not being checked. I already talked a little bit about formal verification. I won't go too much into it. It's an interesting topic, but that's not generally what we do. And another category of testing techniques are in the workflows. And of course, you know, test-driven development. I think if you haven't heard of this, test-driven development is just a workflow where you write a test before you write the code. So the test is testing things that don't exist yet. And why this is a very useful workflow is because it forces you to think about how something should behave before you start writing code. It's a very difficult thing to do in practice. I think if you go look on job listings, etc., there's a lot of mention of TDD, but I myself have never worked in an organization where TDD is fully adopted. There's always pockets of people, of enthusiasts working this way, but it's generally speaking a very difficult thing for people to adopt. And I'll tell you why. I'll tell you why that is: human behavior. Because I've come up as a developer being mostly self-taught, and a lot of developers are self-taught, and they've always worked in a specific way. And telling them to change the way they work is really something that's very difficult to achieve, because they say, well, I've gotten this far using my current workflow, why should I change? Another workflow is basically similar to TDD, but instead of saying we're going to write our tests at any level first, we're going to write our acceptance tests first. It's also known as ATDD, which isn't exactly the same as BDD. I hope that people aren't getting mad behind their keyboard saying, it's not the same thing, it's not the same thing. Okay, sure. But behavior-driven development is very much like acceptance test-driven development, where you're not just writing tests first, you're writing the functional acceptance tests, the ones that tell the business something. So you can write things in plain English that say, okay, if I do this, then this interaction, I expect this output. You can write that in plain English, and a business person can read that and understand that, and that's going to be the first thing you do before you write any line of code. That's different from TDD in the sense that TDD doesn't tell you what type of test you should be doing first. So TDD, BDD, not very different. Depending on who you ask, TDD was always meant to be BDD, except it needed a new label and a new marketing jacket or whatever. It needed to be sold in a different way. So I tried to keep it brief. That's an overview of all the testing techniques. Quite a few, I know. We'll delve into those at a later date. At least I hope so. I would like to give you some examples of that in a future webinar. So let's assume that you're all listening to this and saying, yes, Arjen, get to the point. We all understand the value of testing. So the title of this talk is not just the importance, but also the systemic breakdown of automated testing. So when I say systemic breakdown, I mean within a team, there are certain forces at work. When people work together, they influence each other. There's a product owner, there's us, the developers, there's QA engineer, there's all these roles, and they all form a system of people. And that's why I said systemic breakdown. There's something in that system when it comes, you can think of it as incentives or as knock-on effects, like domino effects, things that are connected, interconnected in directional graphs, let's say. And also in cycles, one thing can affect something else, and then that in turn affects the original factor. So how does systemic breakdown happen when it comes to automated testing? That's going to be the next topic. So We've seen this in a lot of cases, in old cases where quality assurance is a different department's problem. But like I said, we're not talking about different departments. We're talking about agile organizations. And even within an agile team, QA can, in some cases, be the tester's problem. If we have somebody within the team that has the label QA engineer or tester, you still see the tendency to make testing that person's responsibility. But that is, like, even when we say, well, we share that responsibility, very often there's a boundary. There's like saying these categories of tests are your problem and this category of tests is our problem. But the consequence of segregating those responsibilities is that very often tests break and they remain broken for a while because the person that caused something to break has already moved on to the next thing, right? The feedback loop is too long in this case. And also because it's not the person who's looking at the broken functional acceptance tests that has the power to change them. They're constantly dependent on each other. So that's one influence, one line of influence, one causal relationship, which can cause this breakdown. What also happens is the application becomes harder to test because making a system testable is an extra thing you need to account for. It's not like by default code is testable or applications are testable. You need to take extra measures. You need to make certain things reachable, or you need to make certain new endpoints so that something is easier to test. And if you're not the person that requires those measures in order to write the test, if that's somebody else's problem, that person will be stuck with that problem and will have to request help from developers to fix it. So this is a second consequence. Another cause in the breakdown can be when tests are too granular, meaning the focus of a test is too small. It's testing like a very specific thing, detailed thing, which unit tests tend to do. If you're testing the implementation details and not let's say the API, again, this is reflecting the modular thinking. If you're thinking in modules, then there's an outer layer which you want to test and you don't want to care about the implementation details. But if you do test implementation details, your tests will break more often. This is also true when you have a lot of mocks in place, mocks being fictional or fake replacements for components. If you, for example, depend on an external API and you don't want your tests to depend on the real API, you may create a fake API to simulate that, and you will test against that. However, you can go overboard, and when you start creating mocks for things that aren't stable, right? So if an external API is stable, the mock is fine because you don't have to maintain it so much. But if you mock something that is not stable, your tests will break frequently. Again, your tests will break frequently. As a result of tests breaking frequently, frustration with testing grows. I think this is a given, but I'll wrap this up later. Not enough refactoring of tests happens, well, when there's no attention given to those tests. And we'll cover why something like this will happen. Why does test refactoring not happen? As you can imagine, when it's somebody else's problem, that might also be a reason not to refactor, but we'll make that link. If you have an incorrect proportion, incorrect here should be in quotes really, proportion of unit and acceptance tests. So let's say you have a lot of acceptance tests but very few unit tests. What happens is very often acceptance tests are much slower than unit tests. So the tests take longer to complete. And again, frustration with the testing grows. When tests cannot be run in parallel, meaning test A has to finish before test B can finish because they have some type of dependency, some ordered dependency, then that also contributes to tests taking a long time. If you can parallelize them, you can save a lot of time. Also, if you have a lot of repeating steps in your tests, this could also be the consequence of tests that are too granular. This repetition obviously means that a lot of the same steps need to be executed multiple times, also contributes to a long runtime. Flaky tests, that means tests that sometimes fail randomly, right? So tests that you can't reliably say that if they failed, it's an actual bug. Maybe they failed because something like a random number generator, they depend on, maybe they depend on something that's asynchronous and maybe it times out sometimes for some reason and you can't rely on it. That means it's flaky. the result of that also is that frustration with testing grows. And again, tests don't get enough love and attention as a result of that. So we'll see how that links back later. Test coverage degrades over time. What happens when test coverage degrades over time? Well, we have less and less confidence in the system and in the changes, whether or not they broke something. So you start catching defects much later in the workflow. The tester starts finding it, or the user starts finding it, because we didn't catch the bugs early, because there are no tests covering that functionality. As a result, more and more time is spent fixing bugs, and the team slows down, and the quality by definition suffers. Now look at this. I brought it all together. These are all the things we just covered, just linked together. You'll recognize the causal relationships, but basically it all really points directly or indirectly to this frustration with testing, which maybe you feel that. Maybe you feel that in your current team. Maybe you felt it in the past, but I'm sure most of us have felt it at some point that, this testing it's causing us extra work. They're breaking all the time, and I don't know how to make it better. And thanks to that frustration, the tests don't get enough love and attention. As a result, test coverage degrades over time, and we have this one: defects caught late, team slows down, quality suffers. So all of these factors boil down to the breakdown of automated testing. And it's even worse than that, because there's feedback loops. Right? When tests don't get love and attention, that means they won't be refactored as much. And if they're not refactored as much, it means we won't fix the disproportionality of unit acceptance tests. We won't make them parallelizable, and we won't fix the repetition. And all of these things mean that it gets worse over time. There's a negative feedback loop in the process. So I hope you get what I was trying to get at when I say I'm going to look at it as the team as a system, or the project as a system. All of these things have an effect on one another. Now, listening to this, I don't know, maybe you just accept everything I say, or maybe you're a critical viewer and you may have already caught this. But there's something weird about this systemic breakdown, right? There's something weird about this diagram that I'm drawing. It's this one. Because you would assume, or at least if I explain this to a layman, I might get the question, well, if your frustration with this thing is growing, why don't you just fix it? Why would the result or the consequence of the frustration be that you actually spend less time fixing it? Why would you give it less love and attention as a result of the frustration? Wouldn't it be logical to say, give it more attention? So why not just fix it? Long silence. Hopefully that'll trigger some thoughts and some questions. If you have any, put them in the chat. So the two resource problem is my explanation for this, where it's what I've observed. It's subjective, but I'm wondering how many of you will recognize this. This whole why not just fix it question really depends on two things. Like, yes, I would fix it if it's given enough priority, and I know how to fix it. I have the expertise, right? So that just fix it assumes two things. If you don't have those two things, it's not as easy as just fixing it, right? So not giving it enough priority can be the result of pressure. So we're rushing towards a deadline. So it works. I tested it. I verified it manually. So it's done. Ship it. That obviously will come back to bite us, because we want automated regression testing, because we're changing things all the time, right? The next sprint introduces new code, and the next, and the next, and the next. And we want to have this confidence that nothing's broken. So this automated regression testing really is necessary for us to maintain our velocity, our speed, or whatever you want to call it. Also, when it comes to expertise, really all the things I talked about, making things parallel, removing repetition, and fixing the unit and acceptance test ratio, that's really just software design, right? And software design to this day, I haven't really found a good way to learn it and to get better at it other than just experience. I wish there were more resources out there to say, this is the curriculum for software design. Once you've passed this, you're set for life. But there's no such thing as far as I know. No questions yet. I encourage you to ask questions. I'll just keep going. So let's address the first one, the priority question. Well, I think, and this is just a hypothetical scenario, right? If somebody were to tell me, well, I would write tests, or I would improve the test coverage, or I would do write acceptance tests because we currently only have unit tests, something like that, but I don't have time, then again, a thought experiment would be, yes, okay, if you say that, think then about this. Who in your team or outside your team has the right to tell you to build a low quality product? Who is that person? I think in most cases you would say, well, the person paying for the software, right? The person paying for the software has the right to say that. Okay. Is there a scenario where the output, the aesthetics of what you're producing are more important than how it functions? Is that the case? I can't really think of many scenarios where that's true, but maybe that's true. And also, when you're saying, well, the person paying for the project gets to decide whether we build a high quality or low quality product, does this person actually know how to build high quality software and what that means? Does this person know the consequences of not doing that, right? Because usually this person is also putting a very high value on speed. And as we've looked, when we considered all the causal relationships, we looked at the team as a system. Eventually, we'll slow down if we don't give this enough attention. So, does this person, the one that has the right to tell us to build low quality software, does this person understand that? You can imagine in a team where the product owner is telling you, screw the tests, we just have this deadline, and after that, this project isn't going to be maintained anymore, so it doesn't matter. And then, in the end, of course, we still need more changes. The user saw something, they would really like this new feature, so the project gets an extension. And then you say, well, wow, this has a huge impact. I don't know if we can do this reliably. I think this will introduce bugs, there's a risk, and we really haven't written tests. Well, you mean you were taking shortcuts where you weren't doing it right the first time? Well, you never want to be in a scenario where the person pushing you to deliver software has this excuse or has this argument in their favor saying, well, you should have done it right the first time. You want to avoid that at all costs because, well, it's going back to the thing I said before. It's putting your ass where your craftsmanship is. It's like if you care enough about the quality of the thing you're building, you want to really avoid this. This is a really painful thing to happen. So it's actually true, and I've encountered this recently quite a few times when involved with public tenders. When you want to compete for a really a large project, you have to write a really nice proposal, and you have to kind of promise the moon. In these types of proposal scenarios, you very often find that the customers who have been bitten by large projects, by the slowdown of large complex software projects, they will actually require a lot of measures in order to ensure the quality of the deliverable. And this actually very rarely enters the mind or the conversation inside the team. In the minds of the developers is just, well, the thing that we need to do this sprint. The thing we need to do the sprint after also gets attention, but we're not looking that far ahead. Plus, generally speaking, developers don't read contracts. Most people in the team aren't aware of what's in that contract. So it's not rare, it's actually pretty common for large projects to have these types of clauses in the contract saying you have to have tests, you have to have this documentation, really up to a point where it stops being useful. But they've suffered that pain in the past where they had to toss something that never saw the light of day and start over, or just quit entirely because it just became too complicated. So are there reasons not to fix this? Again, why not just fix it? Well, there's also maybe a good reason not to fix it. Is there a good reason ever? I'm not sure, but I can explain why it generally doesn't happen in my eyes. Again, this is subjective, my opinion. Feel free to debate me. I think maintaining software is the least fun thing for a developer to do, especially if it's not your software. Or maybe it's actually worse when it is your software because you want to be done with it. But maintenance just isn't fun. Writing tests for a system that doesn't have tests, or fixing the tests because they're not effective or not well factored, that's no fun. If you add on top of the fact that there's a pressure from the business to deliver something faster, well, you can definitely see how that would mean that the things don't get fixed. So really, it's an easy way out. If the business puts even the slightest bit of pressure on the team to deliver something faster, and it gives a good excuse not to do the not fun thing, the maintenance, well, we may actually be inclined to choose that option because it means we don't have to do the thing that we don't like. Yeah, I don't know. And maybe I'm just speaking for myself, but I feel like this happens. So there's a question in the chat. Is there a way to cost/make visible the price of shortcuts asked, so to quantify it? Very, very difficult because it's like compound interest, but the interest is invisible. So there's this concept of technical debt. Obviously, you know what debt is in real life. That's why I like the analogy. If you have debt and there's an interest rate, the earlier you pay that debt, the less you have to pay in total, right? So it saves you money to pay that debt early. With technical debt, it's similar. The longer you wait, the more expensive it is to fix it. So you know it's debt, you just can't put a number on it. You know it's going to get worse the longer you wait, but you just don't know how to quantify it. So I don't know of a way to say, if you don't do this, we'll do a controlled experiment. We'll do one team, we'll fork the team. One team does it with the practice and the other does it without, and the outcome is clear and is quantifiable. I don't think it's possible. Maybe there's a way that you could do it just using statistics and a lot of samples. As far as I know, I don't know how to do this. Would be interesting if you solve this problem. Marriage asks about behavior-driven development. Does it have to be always at a high level? I mean, I cannot test a method or a unit or maybe a component's behavior if I write the test of the behavior of a unit first, then it is TDD. Yeah, so it's TDD when you don't really specify the level at which you're writing the test, right? You're just writing the test first. But behavior-driven development refers specifically to the behavior, the business-facing behavior, the thing that a business person would read, or possibly also a QA engineer would read and say, I understand this because it's plain English, and then we implement the code that actually implements the English level statements. Generally speaking, that only really makes sense at a very high level. Otherwise, a business person would read it and say, I don't know what this means. Why did you go through the trouble of writing a Cucumber file in plain English if I don't even know what that means, right? I think in practice, BDD very difficult to get right because it requires very close collaboration with a product owner that cares enough about that level of specification. And I haven't worked with product owners like that very often. So the Marriage goes on to say, my question is, what is the distinction exactly between TDD and BDD? I hope it's a little bit clear from what I just said. It's like TDD doesn't specify the type of test or the level of the test. BDD says acceptance test. It's the functional, business-facing side of things that we're testing. Brent says, so this begs the question, how can we make maintenance more fun? Gamify it, I don't know. You could create incentives. Like you could even create a bonus structure, right? But the problem is when you start defining this is known, I believe, as Goodhart's law or Goddard's law, depending on how you pronounce that name, that once you start measuring, once a measure becomes a target, it ceases to be a good measure. So if you start measuring too much how much maintenance people are doing and trying to incentivize that number becomes a target. So people will start gaming it, say, look, right? And it might, even if it's not money, it might just be a pride thing, right? I want to be the highest ranked when it comes to refactoring and maintenance, and that becomes a problem. There's ways, obviously, that you can design a structure to say, well, people won't abuse that. Also, should there be such a thing as maintenance, or should we perceive it more like continued development of an existing product? Well, even while you're developing, so we're not talking about like a life cycle of a project, because of course there's moments when development takes a back seat, and all we want to do is just keep the thing alive and running, like a support mode, end of life, whatever. Even while you're doing the development, there's maintenance, right? Because as you develop, you learn, and you need to refactor all along. And even that gets avoided, because sometimes you feel like we're very close to the finish, we don't need to do this. Or it's not fun, so we can avoid doing it. Refactoring continuously is also maintenance throughout the life cycle. So going back to the presentation, too busy to improve, is it a thing? Well, I think you know my stance on this. I don't think there is such a thing as being too busy to improve, unless there's a very, very rare case. Look at this picture. Now imagine this boat, right? It's being flooded, there's a hole, and this little figure trying to take the water out with a bucket. Maybe this person thinks, well, this boat is on a forward trajectory and we're very close to the finish line. We're very close to shore, right? So maybe I can keep this up until I get there and the boat won't sink. But maybe he won't. And we know how difficult it is to estimate software or software changes, right? So if you think in terms of technical debt, you know you're going to slow down. You just don't know how much you're going to slow down. So it's very, very difficult to estimate whether it's worthwhile staying the course or actually plugging the hole, which means maybe you have to slow down a little bit to plug the hole. But at least you'll know that even if you do have to work for a longer period or the deadline is further into the future than you thought, you'll be able to make it. Now, going back to the segregation of responsibilities, if QA is somebody else's problem, you may get something similar to this, where somebody's trying to fix the issue or trying to save us, but other people feel like it's their responsibility. It's the tester's responsibility. Quality assurance should be assured by the quality assurance engineer. If you separate this too much, even, again, if we're assuming agile teams, multidisciplinary teams, there's still a case where it's specifically somebody's role to catch the bugs and to do regression testing. So yeah, that still happens. Even when the developers write tests, they tend to write unit tests, which are low level and granular, and don't do the thing that functional acceptance tests do, which is guarantee that the behavior, again, there's that word again, the behavior is still working, still functional. So this is really a discipline. Automated testing is a discipline. It's a self-imposed quality standard. You could think of it as something that you put in the definition of done, and I think most teams actually do have something in their definition of done with regards to testing that specify what level of testing needs to be achieved. I think most teams actually do this when they follow an agile methodology framework. Very difficult to find my words right now, but if you work in an agile way, very often you have a definition of done and you put this type of thing in there. And I think especially when you have to convince somebody, the person that's paying the bills, that this is a worthwhile use of your time, the definition of done could be your secret weapon if you use it diligently and you just keep bringing it up, right? It's not done because we haven't done this thing, or we have to take time to write these tests because technically the stories that we did last sprint weren't done because we have this definition of done that says these and these boxes have to be ticked. If you do it seriously, it can be a secret weapon. But it also means that you have to hold each other accountable, because not everybody is constantly, while they're coding, they don't have the definition of done open on their second monitor looking, oh, did I cover all these, right? So you have to be able to remind each other, which means that a team needs to have a certain level of psychological safety or trust. They need to be unafraid of conflict to a degree to be able to hold each other accountable. Now, there's this word culture, right? And I think culture has become a little bit more clear in my mind. There's a couple of words out there that I hear a lot of the time, and I'm like, what do you even mean? Like vision, what does vision mean? And that's slowly starting to become more clear to me. There's also leadership. What does it mean to be a good leader? Like, I wish I could put like a really clear definition there. For me, culture now is just the same thing as unwritten rules. So if you join a new team and you don't know anything about their way of working, maybe there's a definition of done, maybe there's like contribution guidelines, and you can read those and you'll get a sense, oh, this is what the team is like. That's not the culture though. The culture is what you think the unwritten rules are after you've worked with them a couple of weeks or a couple of months, right? Does a person in the team really only care about their part of the system, and yeah, they try to segregate their responsibilities so that their stuff is well done and they don't care so much about the holistic thing, the whole product. They might never say that out loud, but you have a feeling after a couple of weeks, this guy doesn't care about the project as a whole, they just care about their part of the system. That's team culture, right? It's unwritten, but it's understood. And people know this. So even though you never actually say out loud, I don't really care about this job, doesn't matter, it's just a job, people get that sense, they get that feeling like this person is just here to earn a paycheck, doesn't really care if it goes well or bad. That's something you feel after a while. After a while, you get a sense of everybody, how they're in it, and that's the team culture. And you can contrast that to a team where people are constantly holding each other accountable, right? They care about the quality of each individual contributor, right? So if you are constantly in conversations where, well, man, I think you wrote an awesome piece of code, but really without the test, it's not complete. We should put it back to in progress or whatever. Like if people are constantly having those types of conversation, that becomes the unwritten rule that you don't even have to put it in a definition of done. People will get the sense that, okay, this is the way that this team functions. This is the level of quality that is expected. So that being said, there are scenarios where people, in the name of quality, just go too far. Say, well, you can't do this. This is a horrible design. And they become very passionate about the code that's being written. And it's good that you care about quality, but it can be counterproductive if you start to go too much into details. Like, for example, it can become something that's more akin to bike shedding, like tabs versus spaces. Do I care? It doesn't really matter so much. I think it's here or there, right? And it becomes a slightly different conversation when you say, should this thing be a separate class? Well, maybe we need to separate it because we'll need to reuse it later. But then the argument might be, well, why don't we wait until we need to reuse it before we separate it? It looks fine the way it is now. There's a point of diminishing returns where you need to stop having that conversation and just make a choice. Back to the system view of the breakdown. Frustration with testing doesn't have to mean that you don't spend time fixing things. But it requires you to have time and the belief or conviction that that's the right thing to do. And that conviction thing, that has the link with team culture or just culture in general. Like if you have a team culture where automated testing is a super high priority, then you have the conviction. If you also have the time, frustration with testing will actually have a negative effect on the block beneath it, which in the end is positive. So it would have a negative feedback loop on the way it's drawn now, which means that actually it would dampen the effects of the red box, which says defects caught late, team slows down, etc. You would, in the end, have a much a much more positive feedback loop, right? You would have a virtuous cycle instead of a vicious cycle, and automated testing would not break down, but instead improve if you have the time and the conviction. What can you do? Well, I think everyone in this webinar will have some thoughts and ideas of what they can do. This is just my sampling. I think one thing that's very obvious is that at the team level, decisions can be made about this. You can do things individually. You could set a standard for yourself, and maybe that's a logical place to start. But very soon after that, in order to stay motivated, you will have to convince others as well. And I think one of the first things you have to do is agree as a team that developers are primarily responsible, not solely responsible, primarily responsible for writing and maintaining automated both unit and acceptance tests. You can put this agreement in the definition of done, but then you also have to remind each other about the definition of done and actually use it in your daily work. There's the do not repeat yourself or dry principle, which applies to any code, including testing code. If you're going to refactor your code, your tests are code as well. You should refactor that as well. You should maintain that and keep them clean, remove duplication. Otherwise, that frustration with testing will start taking its toll. If you need to keep them fast, you can write journey tests instead of very granular tests. If you have one test per story, very soon the number of tests will grow so high that your acceptance tests will start to be too slow to be practical. So you can chain them together into a journey test, which will be much faster. That's another thing you can do. The other stuff, that's really just like a sort of mindset. Just don't tolerate flaky tests. Address them as soon as possible. Make an effort to parallelize as much as possible to keep the runtime low. And when you're going to mock something, make sure that you're mocking something that's stable, and only do it if it enables you to test something that you would otherwise have to wait until an end-to-end test to test properly. So if you can cover a piece of functionality in a unit test through mocking that otherwise would only be testable in an end-to-end test at a system level, then yes, definitely go ahead and mock it. It'll bring the pain forward. So going back to the thing I said about you can go too far, there's a story of how unit testing and unit testing mindset and culture was introduced at Google, and I have a link to this story for you, which you can read. One of the nicest parts of the blog article is this part where they're talking about how somebody emailed or messaged the person that came up with this testing grouplet testing grouplet, which is the organization inside Google which was there to promote unit testing. So here's the story. There was one new Googler, I guess, in Sydney that instant messaged me on a tip that I was a person who knew people, asking me to talk to that team to persuade them to allow him to submit a change to improve the testability of a particular component. So this person sent him a message saying, please convince my team to do this thing, because this thing I'm doing is to improve testing, right? They had this feeling of righteous conviction that they were doing the right thing. He decried their lack of testing discipline rather desperately, until I told him that the team lead used to run the testing grouplet, and that the test certification, which they invented at Google, was modeled after that team's process and policy. Humbled, he resumed the conversation with the team, resulting in a satisfactory conclusion. So this person was complaining about the lack of test discipline, but in fact, that was the team that was used as a blueprint for testing practices within all of Google. So there's a very good example of how you can go too far when it comes to fighting for quality, because very often you kind of mix your own pride when you write code. Because coding is a creative activity, and so there's a lot of pride attached to the quality of this thing you're writing. There's a very interesting story. Just Google test certified, It's on a blog of a person called Mike Bland. Very interesting story. Test Certified is the name of the certification program that they invented internally, which is meant really to change the testing culture within all of Google. Quite an interesting story and very inspiring. With that, I've come to the end of the talk, and I hope that maybe there are questions, even though we went a little bit over time. I thought this was going to be a half-hour thing, but I spoke a lot, and my throat is a little bit dry even. Do you guys have questions?